Hello everyone, myself Sajja Tulasi Krishna, working as an assistant professor in CSE Department of Vignans deemed to be University. In today's lecture, we are going to learn about the sorting. So here sorting means in general way, we are arranging an objects into an order. So that is the general meaning of sorting. But in computer language also, the same meaning is applicable for sorting. We are arranging a set of data. Here set of data means the data here contains either numerical or characters or alphanumerics. So these are refers to the data in computer language. So this data is arranged in some logical order. So logical order contains either ascending order or descending order. So these two orders we are called it as logical order. So here the definition comes to the point. The sorting is refers to arranging the data in either ascending order or descending order. So let's see a simple example which is based on the numerical data. See here the data is present in the array. So this data is present in the numerical format. So in numerical format, this data is not arranged in proper order. So that's why this is called as unsorted list. After arranging either in ascending order or descending order, then those lists are called as sorted list. Unsorted list means the data is not arranged in any proper order. Sorted list means the data is arranged either in ascending order or descending order. Those lists are called as sorted list. So now coming to the characters. So here also this list contains unsorted order. So after sorting either in ascending or descending, the characters are arranged in order wise. So this is the example for characters. Now coming to the alphanumeric values. Alphanumeric means, so here alpha means alphabets and numericals means digits. So both are the combination we are using the list. See here it is character and this one is digit. The combination of both are we are called it as alphanumeric. So in this, how we can sort the list? So based on the first character, what is present in the first character, we will see that first. So coming to simple two elements in the list. So T and L. Which is first one in alphabets? L. So L is before the T. So if suppose in case of these two, see here T1, T2. The first letters of both numbers are same. So then we will go for the second number like in dictionary. So likewise we have to order this unordered list into ordered list. So that ordered list is also called as sorted list. So those are also arranged in either ascending or descending way. So now see, need to sort these lists, unordered lists. So how we can sort? First, let me know what is the need of sorting. So why we are doing this sorting operation on this data? So why means, say here. So you can locate the items easily. For that purpose we are doing the sorting. So if suppose if you are placed any items in unordered way, is it easy to locate the items? No. So to locate the items in easy way, we can sort the list. So then those are prefer to get easily in faster way. So then the main one is to reduce the searching complexity. So that is one of the major need to do the sorting. To search any element in the list, for that purpose we are doing the sorting. So for these two cases, we are done or going with the sorting. So that is the need of sorting. First one is to locate the items in faster way and then reduce the searching complexity in the list. So now see, we are doing sorting techniques in two ways. One is internal sorting and another one is external sorting. With the help of these two sorting techniques, we are done with the unordered list into ordered list. So how it will happen, we will see. First coming to internal sorting. So this internal sorting is mainly done in main memory. So main memory means primary memory. In primary memory, the data is sorted in case of internal sorting. So that's why it is fastly accessible. Prime memory is fasterly we can access the data. So then when we are sorting this internal sorting, so when the data set is small, then only the internal sorting is possible because the main memory is having the less capacity. So coming to the examples of internal sorting, these are the examples: bubble sort, insertion sort, selection sort, quick sort and internal merge sort. So these sorts are the example for the internal sorting. So this sorting is happened at main memory, which is fastly accessible, but it is happened when the data is small. So that is called internal sorting. So now coming to the second sorting, that is external sorting. So this external sorting is not happened into the main memory. This is not happened in main memory, which is happened at external memory. So that is secondary memory. So this type of sorting is happened when the data set is large. So if your data set is small, then you can go for the internal sorting. If your data is large, you can go for the external sorting. So the example for the external sort is external merge sort. So already we are having merge sort two types, internal merge sort and external merge sort. So internal merge sort is done with internal sorting. External merge sort is done with external sorting. So now coming to our CPDS course, we are having only three types of sortings in this course. Those are bubble sort, insertion sort and selection sort. So let me explain these three types of sorting to sort your unordered list into ordered list. So first let me see about the bubble sort. So now coming to the bubble sort. So this bubble sort is very simplest technique and very oldest one. So in this bubble sort, we are sorting two consecutive numbers. Means consecutive numbers means side by side numbers. So those side by side numbers are sorted. Likewise, the entire data set is sorted. So how it will happen means the first element is compared with the second element. While the comparison of this one, the first element less than second element means the second element is highest one. So obviously second element is highest one means there is no swap. Okay. So if suppose the first element is greater than the second element, so the swapping is done. Because here all the sortings are done with the ascending order. So preferably we are doing with ascending order only, not descending order. So for that purpose I am said the first element is less than the second element. means the second element is bigger one. So in ascending order, likewise the first element is smaller one, second element is bigger one. So this is correct one. So that's why no need to swap the elements. So in the second case, the first element is bigger than the second element, means we have to move the first element to second place. So swap is happening. So likewise, continue this process in entire the list until all the elements are in correct position. So one speciality with the bubble sort means in each stage, means in each pass, the largest element is placed in its proper place. See with the example what I am saying in before. So the first, is this sorted list or unsorted list? Unsorted list. So now with the help of bubble sort, we will sort this list as sorted list. Now see, coming to the first pass. Here what we are doing in first way, that is called as first pass. So in first pass, what we are doing here, compare these two elements. Okay, first the consecutive elements are compared. Consecutive elements means side by side elements. So now compare 4 and 6. What are the conditions are placed here? See here, the first element is compared with the second element. So now first element less than second element. Is it true or not? The first element is 4 less than second element. So 4 less than 6. Is it true? So yes. So the condition is now false. So see here. Here the condition is false. No need to swap these two elements. Okay. So now coming to next one. So next consecutive elements. Next side by side elements we will compare. Now see. This is the first element now. This is the second element. The first element is greater than the second element. Now the condition is coming to second one. First element is greater than second element. So the condition is true now. So now here we are doing the swapping operation. So swapping means, so the 1 is come here, 6 is comes here. So now see, 1 is come here, 6 is here. So the swapping is done with the help of this before statement. So now coming to compare with next consecutive locations. So these two now we are going to compare. 6 is greater than 5. The first element is greater than second element. So the condition is the first element is greater than second element. Is it true or not? Yes, the condition is true. So now we are going to swap these two elements. So now see, these two elements are swapped. 5 and 6 swapped. Now compare these two elements, 6 and 8. So now the condition is 6 is less than 8. So this is higher element. So no need to swap. The condition is false. No need to swap here. So now we will compare the next two elements, last elements. Now the first element is greater than the second element. So we need to swap here. So the condition is true. So we have to perform the swap operation. So now the list is comes with 0 and 8. So see here, after completing all the elements in the list, finally the last element, that is the largest element, is placed at the end of the first pass. So that is happened in bubble sort. So the first pass is over. Now see the second pass. For the second pass, this is the output of the first pass. Is it right or not? We are not taking the unsorted list again. Okay. So for the second pass, we are taking the input for the second pass is output of the first pass. Okay. So we will see the second pass. Again, the same procedure we have to repeat. So compare with the first two elements, that is 4 and 1. The 4 is greater than the 1. So now the condition is true. So we will swap the two numbers. So true the condition and we will swap these two numbers. So now see 1 here, 4. The two numbers are swapped. So now coming to compare these two numbers. 4 is less than 5. So now the condition is false. So there is no need of swapping. So 4 less than 5. So now see. Compare next two numbers. These two numbers. 5 is less than 6. So now the condition is true or false. So false. So there is no need of swapping. So now see. 5 and 6 are same place. So now compare next two numbers. Now 6 is greater than 0. Now the condition is true. So there is a swap between these two numbers 6 and 0. So now see 0 is placed here, 6 is placed here. So all the numbers are compared. No need to compare with this last number. Why? Because already the last number is placed at the end of the list. That is comes from the first pass. So now we no need to compare with this last element because it is already placed in proper position. So we need to compare up to here only. So now all the comparisons are done. So now the second largest element is placed in its right position. Okay. So after second pass, second largest element is placed in its right place. Okay. So we will see the third pass. So what is the input for the third pass? The second pass output is the input for the third pass. Say here. So now no need to compare these two elements. The comparisons are made up to these four elements in pass 3. Okay. So now see. Again repeat the same procedure. So now compare these two elements. So now 1 is less than 4. So now the condition is false. So no need to swap here. So now the next comparison is made with next two elements 4 and 5. So now 4 is less than 5. So is there any swapping? No. So the condition is false. So no need to swap these two elements again. So now see. Now the comparison is done with these two elements. Here the 5 is greater than 0. Now the condition is true. So we need to swap these two elements. Okay. So now see 0 and 5. 5, 0 are swapped in its positions. So 0, 5. So is there any elements are there to swap? No. Because no need to swap these two elements. Because those two are already proper positions. So now what's happening? The third largest element is placed in its right position. Okay. So up to this clear? So now see in pass 3 the third highest element is placed in its right position. So now again we need to sort these three elements. So we have to continue the same process. So now coming to the pass 4. What is the input for the pass 4? The output of the pass 3. Okay. See here. So now no need to compare these three elements. So the comparison is done with only these three elements in pass 4. So now repeat the same process. See here, again compare 1 with 4. The condition is again false. No need to swap here. Again, the comparison is done with the next two elements. 4, 0, 4 greater than 0. So now the condition is true. So we need to swap these two elements. So now the fourth position is filled with 0 and 0 element is filled with 4. So swapping is done. So is there any elements are left to compare? No. So now the next largest element is placed in its proper position. Okay. So now coming to next comparison with two more elements. So let's take another pass. Okay. So next pass. Already these elements are sorted order. So now check with the pass 5. Again compare with these two elements. So now 1 greater than 0. Is it true case or false case? True case. So swap these two elements because 1 is greater than 0. So now see 0, 1. So is there any chance to sort remaining elements? No. So now see the next position is filled with the next largest element. So in coming to next phase, how many elements are remaining? Only one element. Is comparison possible with this one element? No, because the element is already placed in its right position. So now the list is sorted or not? Yes, sorted. 0, 1, 4, 5, 6, 8. So for fifth passes, we have to complete all the elements are sorted in right way. So how many elements are present in the array? 6 elements. So for 6 elements, how many passes we need to have complete the sorting? 5 passes. Means if n elements are present in the array, so n minus 1 passes need to complete the sorting. This is the important one. How many elements are there in the list? N elements. How many passes we have to take to complete the sorting? In bubble sort, n minus 1 passes. Okay. So now see the complexity of the bubble sort. So here complexity means, so we have to take how many passes to complete the process. So first, how many elements we need to compare? n minus 1 elements. So with n minus 1 elements, the first pass will complete. After that, n minus 2 elements, because the one element is placed after the first pass. So we need to compare n minus 2 elements. So likewise, for the single element, up to single element, we have to complete all the passes. So this is the formula for n into n minus 1 by 2. So we have to convert this into the notations. So that is big O of n square is the complexity of the bubble sort.